Welcome back to the Deep Dive. Today, I want to start by taking you to a very specific place and time. It's Monday, it's spring, the year is 2019.
Okay, I'm with you. Set the scene for me. Where are we?
We are in Redmond, Washington. We're standing inside the Microsoft headquarters, but we are not in, a typical cubicle farm or a software lab.
Right.
We're standing next to a man named Jason Zander. He's the Executive Vice President of Microsoft Azure. And we're looking out at a facility that feels, well, it feels like it shouldn't belong to a software company.
What are we looking at? What's the vibe?
It's called the Azure Cloud Collaboration Center. And honestly, it looks like something out of a techno thriller.
Oh, wow.
Yeah, it looks like NORAD or, a NASA mission control room. We're talking about these massive, massive walls of screens, data streams, pulsing in real time, world maps just lit up with traffic spikes, news feeds scrolling by. It is a literal nerve center.
Which is, that's entirely appropriate because by 2019, that room was effectively the engine room of the global economy.
Right.
If that room goes dark, a significant chunk of the world just stops working.
Exactly. And that's what we are digging into today. We're looking at the cloud wars. But I want to be clear right off the bat. This isn't just a tech story about, servers and fiber optic cable.
Yeah, it's much bigger than that.
It's a business thriller.
Yeah.
It's the story of how Microsoft, a company that, let's be honest, was seen as a dinosaur, the legacy giant of the desktop era, managed to pivot.
And not just pivot, but to challenge Amazon.
To challenge Amazon.
Amazon was the undisputed king at this point. They were the massive first mover. They basically defined the entire category.
Right. And then you've got Google, this terrifying tech titan, trying to claw its way in from third place. So you have this massive three-way battle for really the future of the internet.
And I think this is why today's deep dive is going to be so interesting. We aren't just going to recount the business moves. We're not just going to talk about market share and quarterly earnings.
No.
We are going to layer something else on top. We have a stack of research here, particularly from Melissa Schilling, on the actual theory of innovation.
This is the part I'm so excited about, because usually we just say, oh, that company innovated. But we rarely stop to ask how. Like, what does that even mean biologically, sociologically? How does a massive organization suddenly get a new idea? How does creativity actually work in a high-stakes environment like this?
Exactly. We're going to look at the science of creativity. We're going to talk about concepts like user innovation, what's called the outsider advantage, and, why the whole idea of the lone inventor is mostly a myth.
And we are going to see how those theories perfectly explain Microsoft's survival. Because the story of the cloud wars, when you really get down to it, it's a story about clashing philosophies. It's open source versus proprietary. It's the cathedral versus the bazaar.
It really is. It's a clash of entire worldviews played out in server racks and code repositories.
But before we get to the high-stakes warfare, and before we get to the theory, we have to address the elephant in the room. We have to talk about the old Microsoft.
Oh, you mean the evil empire.
I didn't want to say it, but yes, that's the one. If you grew up in the 90s or the early 2000s, what was Microsoft? What was the vibe?
It was the company of no. It was the Death Star. It was Steve Ballmer on stage, screaming, developers, developers, developers.
So much sweat.
So much sweat. It was a company built on a fortress of intellectual property. You pay the licensing fee, you get the CD-ROM in a cardboard box, and you do not ask questions. And most importantly, you do not see the code.
Right. Closed source.
Yeah.
Open source is a cancer. That was the famous quote from Ballmer.
He actually called Linux a cancer.
He did. And yet,
right,
the Microsoft we see in this 2019 snapshot, the one watching the screens in that NORAD-style control room, is just radically different.
It is a complete 180-degree turn. Under Satya Nadella, they went from actively trying to kill open source to being one of the biggest contributors to open source on the entire planet.
That's a pivot that shouldn't be physically possible for a ship of that size. It is like an aircraft carrier doing a handbrake turn. So we need to unpack how that happened. But first, let's go to the theory. Because if we understand how innovation works in the abstract, we can understand how Microsoft pulled this off in reality.
Let's do it.
So we throw this word innovation around constantly. Corporations love it. We're an innovative solution provider. But let's get pedantic for a second. What does it actually mean?
It's one of those buzzwords that's been beaten to death.
Yeah.
But if we look at the Schilling text, which is our academic anchor for today, there's a very specific definition. Innovation is not just having a weird or cool thought.
Okay.
That's creativity.
All right, so distinguish the two for me.
Yeah.
Where is the line between them?
So creativity is the ability to produce work that is both novel and useful. It's the spark. It's the idea. Innovation is the implementation of that idea into a new device or process.
So it's the follow-through.
It's the heavy lifting of making it real.
Okay, so having the idea for a flying car is creativity.
Right.
Building a flying car that actually works, getting it regulated, mass-producing it without it falling out of the sky, that's innovation.
Precisely. Innovation is where the rubber meets the road. And here is where the research gets really counterintuitive. If I asked you, who is most likely to invent a better surgical tool, who would you say?
Well, I'd say a surgeon. I mean, they're the ones holding the tools all day long. They know what's wrong with them. They know the pain points better than anyone.
That's the logical assumption, and it is very often wrong.
Why? That makes no sense to me.
Because of a cognitive trap. It has a few names, but one is functional fixedness, or you could call it the knowledge trap. When you're an expert in a field, you know the rules too well.
You're too close to it.
Way too close. You know exactly how things are supposed to be done.
Yeah.
You know all the safety protocols, the history, the limitations. You get trapped in the existing paradigm.
So you can't see the forest because you're too busy inspecting the bark on every single tree.
Exactly. You know why 10 previous ideas failed, so you stop trying to find the 11th. To solve a really hard problem, you often need someone who has, frankly, no idea what they're doing.
An outsider.
You need an outsider, someone who brings a completely different cognitive map to the problem.
The Schilling text had this incredible example of this, the pill cam.
Oh, this is a classic. It's one of my absolute favorite case studies on this topic.
So let's walk through this. For years, gastroenterologists, stomach doctors, were trying to figure out how to see inside the small intestine.
Right, which is this long, winding, dark tunnel inside us. Very hard to navigate.
And the only tool they had was the endoscope.
Which is, let's be honest, a modernized stick. It's a long, flexible rod with a camera on the end that they shove down your throat.
Not pleasant.
Extremely unpleasant. And it has limits. It can only push so far before the loops and turns of the intestine just stop it cold. So the medical experts, the insiders, spent years trying to optimize the rod.
Okay, so they were thinking,
let's make the rod thinner. Let's make the rod more flexible. Let's improve the fiber optics on the rod.
They were completely stuck on the rod paradigm. They couldn't even imagine a solution that wasn't a stick.
They were building a better stick. And then enter Gavril Idon.
Who was not a doctor.
No, not at all. He was a guided missile designer for the Israeli military.
I love that. I design things that go, boom, let me take a look at your stomach.
But that's the magic. That's the whole point. He looked at the problem of the human gut and he didn't see a medical procedure. He saw a winding tunnel that needed to be navigated autonomously.
He saw it as an engineering problem.
He had no bias toward rods or wires. What he did know about was miniaturized electro-optical technology, the kind of stuff you put in the nose cone of a missile to help it see its target.
So he thought, why push a stick through the tunnel? Why not just send a little independent agent through it?
Exactly. He applied what psychologists call remote association. He connected two completely unrelated fields-guided munitions and gastroenterology. And from that connection, the pill cam was born.
A tiny capsule you swallow.
You just swallow it. It travels through you naturally, taking pictures the whole way and transmitting them out to a receiver you wear on your belt. No wires, no rods, no unpleasantness.
That is such a perfect example. The doctors literally couldn't have invented it because their own expertise blinded them to the possibility.
That's the knowledge trap in action. The more you know about the current solution, the harder it is to invent the next one.
There is another example in the research that feels even more relevant to our modern world, and that's cultured meat.
Yes, this is a massive, multi-billion-dollar industry now, but the origins are fascinatingly outsider. We're talking about growing meat from cells.
Yeah.
No slaughterhouse, no raising animals.
Clean meat, as it's sometimes called.
Right, and the context here is urgent. The demand for meat globally is just skyrocketing as developing nations get richer, but the environmental cost is staggering.
I saw the numbers in the sources. They're wild.
There was an Oxford study mentioned that said cultured meat could require 99% less land and 96% less water than traditional beef.
99% less land? I mean, that's hard to even comprehend. That's basically free real estate for the planet.
It is a complete game changer. But here's the thing. The traditional meat industry companies like Tyson or Cargill, they weren't rushing to invent this back in the early 2000s.
No, they were focused on their current system.
They were focused on how do we make the cows grow faster? Or how do we make the feed cheaper?
They were optimizing the existing cow.
Exactly. And it took a guy named Jason Matheny. He wasn't a food scientist. He wasn't a cattle rancher. He was a public health student.
So what did he see that the ranchers and the big ag companies missed?
He saw the incredible inefficiency of the system. He looked at a cow and he didn't see an animal. He saw a bad machine. A bioreactor.
A bad machine. How so?
It takes about 23 calories of grain input to get 1 single calorie of beef output. That is a terrible, terrible conversion rate. So he thought, this is an engineering problem. How do we bypass the animal entirely?
And because he wasn't trapped in that farming mindset, he started an organization called New Harvest. He approached it like tissue engineering, not like agriculture.
And look who funded the early efforts. It wasn't the farmers. It was Sergey Brin from Google. It was Uma Valetti, a cardiologist who actually left his medical practice to start a company called Memphis Meats.
A cardiologist, that's interesting.
It's another outsider. Valetti saw clogged arteries every single day and thought, if we grow the meat from cells, we can control the fat content, we can make healthier meat.
Again, it's that outsider perspective. The cardiologist sees meat as a health variable, not a commodity. The public health student sees it as an inefficient system.
So keep this concept locked in your mind, the outsider advantage. Because when we get to the cloud wars, we are going to see Microsoft, the ultimate insider of the PC world, forced to become an outsider in order to survive in the cloud.
Okay, but before we get there, there's another source of innovation we need to define. We've talked about these brilliant individuals like Idan and Matheny. What about us, the users?
User innovation is huge. And it completely challenges the traditional idea that companies invent everything and then we just buy it. Sometimes the person who invents the product is just the person who desperately needs it to exist.
The text mentioned the laser sailboat.
Right. This wasn't designed by some huge boat manufacturing conglomerate. It was designed by Olympic sailors for their own personal use.
What was their problem?
They just wanted something simple, fast, and easily transportable that they could toss on a car roof. They built it because they wanted to sail it, not because they did a market focus group. The market came later.
And then there's the superglue story, which, honestly, that one made me wince a little bit.
It is a vivid one. So superglue, the chemical name is cyanoacrylate, was originally just a strong commercial adhesive, nothing medical about it. But in 1983, there was a horrific fire at the Bradford football stadium in the UK.
A really tragic event.
Terrible. And the hospitals were completely overwhelmed with burn victims. They needed to attach skin grafts, but they couldn't stitch them on fast enough. The standard procedure using sutures was just too slow for the sheer volume of patients they were seeing.
So what did they do? They were in a crisis.
The doctors, in a moment of sheer desperation, started using off-the-shelf superglue to attach the skin grafts.
They literally used the hardware store approach to surgery.
Effectively. And it worked. It worked so well that this user adaptation eventually led the company, Loctite, to develop a proper, sterilized, medical-grade version called Dermabond. But the innovation didn't come from the R&D lab at Loctite. It came from the emergency room. It came from the users who had a problem the product didn't even know it could solve.
I love that. It completely turns the company invents, customer buys model on its head.
It's a fundamental source of new ideas.
Okay, so we have outsiders, we have users, but we can't ignore the big guys, the firms.
No, and we shouldn't. In developed countries, private firms are the primary engine of innovation. They spend way, way more on R&D than governments do. But there's a really important nuance in what kind of research they do.
Okay.
Firms usually focus on applied research.
Which means solving a specific problem to make money.
Exactly. How do I make this battery last 10% longer? How do I make this phone screen brighter? They rely on universities and government labs to do the basic research, the pure science for the sake of science.
Like, how do electrons move? Or what is the fundamental nature of gravity?
Right. Things that don't have an immediate commercial application. And the real magic happens when those two worlds collide.
The basic and the applied.
Exactly. The most powerful source of innovation isn't a lone genius or a single lab. It's the linkage. It's the network. It's what the research calls a technology cluster.
Like Silicon Valley. That's the obvious one.
The prime example. But the text also mentions the knitwear district in Modena, Italy.
Okay, I did not expect to be talking about Italian sweaters today, but I'm intrigued.
But it's the exact same principle. Why are the best knitwear companies all in one small town in Italy? Why are the best tech companies in one valley in California? It's because of something called tacit knowledge.
Okay, define that for me. What is tacit knowledge?
So there's explicit knowledge, that's the stuff you can write down in a manual. Recipes, lines of code, blueprints, you can email that across the world.
Right.
But tacit knowledge is the complex, unspoken know-how. It's the feel of the material. It's the intuition of how to debug a failing server cluster at 3 a.m. You can't write it down in a book. You only learn it by watching someone or talking over coffee or seeing how a mentor holds a tool.
So you have to physically be there.
You have to be physically close. Proximity matters. That is why these clusters form. Knowledge literally spills over from one person to another, from one company to another, just by breathing the same air.
Okay, so we have our theoretical toolkit. Innovation requires creativity, which is being both novel and useful. It often rewards the outsider who breaks the rules. It can come from users who are desperate for a solution, and it thrives in these dense networks where this tacit knowledge can flow freely.
That is a perfect summary of the foundations.
Yeah. Let's take that toolkit and travel back to Redmond. Let's look at the giant.
The sleeping giant.
Let's paint the picture of the old model Microsoft, the cash cow.
Oh, yeah. We're talking late 90s, early 2000s. Microsoft's business model was, you could argue, one of the best in the history of capitalism. It was incredibly high margin with almost no marginal cost. They sold licenses.
I remember this so vividly. You'd go to a store like CompUSA. You'd buy a cardboard box. Inside was a CD-ROM and a booklet with a 25-digit key code on the back.
That key code was everything.
You put the CD in, you type the code, and boom, you owned Windows 95. And Microsoft kept almost all of the money. End of transaction. Until 3 years later, when they sold you the next box.
And the marginal cost to them, the cost of printing that one extra CD was pennies. The profit was massive.
And what about for businesses? For the enterprise?
It was the same thing, just with much bigger numbers. It was the on-premise era. If you were a company, say Coca-Cola, and you wanted email and a database, you bought your own physical servers.
Right. You had a server room.
You put them in a closet or a basement. You bought a license for Windows Server. You bought a license for SQL Server. And you hired an IT guy to sit in the closet and watch the blinking lights.
And Microsoft loved this model.
They loved it because it was a monopoly, a fortress. And because the code was closed source, that was their crown jewel. Nobody could see how Windows worked. If you wanted to fix something or change something, too bad. You had to wait for Microsoft to do it in the next version. It was a cathedral of proprietary code.
So why on earth would you change? If you're literally printing money, why rock the boat?
And that is the classic innovator's dilemma. When your current business is that good, that profitable, it is almost impossible to pivot to something new, especially if the new thing makes less money at first.
But the ground was shifting beneath them, whether they like it or not.
It started as far back as 2005. Ray Ozzie, who was the chief technical officer at the time, he wrote this now famous memo.
I love these internal memos. They always sound like these ancient prophecies in hindsight.
It was called the Internet Services Disruption, and he basically warned the entire company. He said, look, the world is moving away from software you install on a PC. It's moving towards services you access over the internet.
So this was the birth of the cloud for Microsoft.
This was the moment. They started a project called Project Red Dog.
Great name. Sounds like a covert op from a spy movie.
It kind of was. It was a skunkworks project, kept quiet. It would eventually become Azure. But here's the thing. It wasn't an immediate hit. Not at all.
Why not?
Internally, the Windows team hated it. They saw it as a distraction. They asked, why are we spending resources on this when Windows is the golden goose? And externally, nobody took it seriously.
Because Amazon was already so far ahead.
We'll get to Amazon in a second, but the real shift for Microsoft, the cultural earthquake, happened in 2014. Steve Ballmer steps down. Satya Nadella steps up.
And Nadella was a very interesting choice. He wasn't a sales guy like Ballmer. He wasn't a Windows guy.
No, he was a cloud guy. He had been running the server and tools division. He knew the future wasn't the desktop. And he famously said they needed to move from a know-it-all culture to a learn-it-all culture.
It sounds like a nice phrase for an HR poster, but what did it actually mean for the business? How did that translate into action?
It meant eating humble pie. Massive, massive slices of it. I found this quote from Julia White. She was the corporate VP of Azure Marketing, and it's really telling. She said, our heritage of closed technology put us in a bad spot, and we got a black eye from that.
Wow. Admitting you have a black eye is incredibly rare for a corporate executive. That's real candor.
It is. They realized they had been fighting the wrong war for a decade. They were fighting to protect Windows while the rest of the world was moving to open source and the cloud. Nadella's strategy was to stop fighting open source and start embracing it.
To stop being the empire.
To start being a partner.
And to shift the entire business model.
Mm-hmm.
Julia White used this great analogy. We used to sell them the kit to build the car. Now we're selling them the ride.
That is the most perfect way to understand the shift from boxed software to cloud services.
Okay, let's pause on that car analogy for a second. Because the cloud is still this vague, nebulous term for a lot of people. The sources break it down into 3 specific layers. If we want to understand the war, we have to understand the terrain.
Absolutely. It's crucial. Think of the cloud as a stack of services, one on top of the other.
Okay, so let's start at the bottom, layer 1.
That's IaaS. It stands for Infrastructure as a Service. This is the raw materials, the steel, the rubber, the glass for your car.
So in cloud terms, this is what?
This is raw computing power. You are renting the physical server, the hard drive space, the networking cables from Microsoft or Amazon.
So instead of building my own data center in my basement, buying the servers, buying the AC units, paying for the electricity, I just rent their computers by the hour.
Precisely. You are still the mechanic in this scenario. You're just renting the garage and the hydraulic lift. You still have to manage the operating system and the security updates, but the physical hardware is someone else's problem.
Okay, that makes sense. Now, layer 2, the middle one.
PAPTR, PAPNA, that's Platform as a Service. This is like the chassis and the engine of the car. These are the pre-built tools you need to build your application.
So things like database management systems.
Exactly. Database management systems, development tools, operating systems, things you don't want to build from scratch. I mean, you don't want to code a database from the ground up. That's reinventing the wheel. You just want to use a database tool that already exists.
So with PAS, I'm renting the workshop and all the precision tools. I focus on the design of the car. They handle the heavy machinery. I don't worry about patching the server. I just write my code.
You've got it.
And then the top layer, the one most of us interact with.
SaaS, software as a service. This is the finished car. You just get in and drive. This is Microsoft Office 365, Gmail, Salesforce, Dropbox.
So you don't care about the server. You don't care about the database code. You don't care about any of it.
You just want to send an email or store a file. The car just works.
Got it. So IaaS is the raw metal. PaaS is the tools in the factory. SaaS is the finished product you drive off the lot.
And here is the fascinating business twist that came out of this stack, what the sources call the profitability paradox.
Ooh, tell me about the money. Where is it?
In the old world, the money was in the software, right? The SaaS equivalent.
Yeah.
The very high margins. But in the cloud, Microsoft and others found that the middle layer, PaaS, the platform, was becoming less and less profitable.
Why would that be?
Because of open source.
Of course. If I can get a really good engine for free, why would I buy yours?
Exactly. If the best database tool, something like MySQL or PostgreSQL, is free and open source, Microsoft can't charge a huge premium for their proprietary SQL server anymore, or at least it's much, much harder. So the value got squeezed, the margins moved to the edges of the stack.
So where is the money now? Where did it go?
The SaaS layer, the finished software like Office 365, is still very high margin, but strangely, the IaaS layer, the raw infrastructure, became a massive, massive business.
I thought you said the margins there were thin.
They are. They're razor thin,
Yeah.
but you make up for it on sheer scale.
You have to be absolutely massive to make the math work.
You need to be titanic. We are talking billions and billions of dollars in capital expenditure just to build the data centers. You need to buy enough hard drives to fill a football stadium. It's a scale game.
And that high cost of entry,
Right.
that huge barrier
Yeah.
that leads us directly to the combatants, because only a handful of companies on Earth have the wallet to play this game.
Section 3, the Cloud Wars. Let's meet the fighters in the ring.
First up, the heavyweight champion, the first mover, Amazon Web Services, or AWS.
AWS is the 800-pound gorilla in this story. But what's so fascinating is that their origin story fits the user innovation theory we talked about at the very beginning.
Really? How so? I don't think of Amazon the store as a user.
But think about what they use. Amazon, the retailer, had these massive, insane spikes in traffic. Black Friday, Cyber Monday, the Christmas shopping season. To survive those spikes, they had to build a colossal IT infrastructure.
But in, say, July, nobody is buying anything. The servers are just sitting there.
Exactly. So they had this world-class, custom-built supercomputer network that was sitting idle for 10 months of the year. They had solved their own problem, which was handling peak traffic. And then, as the legend goes, they looked at all that idle capacity and thought, why don't we rent this out?
So they didn't set out to invent the cloud computing industry. They just wanted to monetize their spare bedrooms.
Effectively, yes. It was an accidental empire. They launched AWS in 2006.
2006. I mean, that is ancient history in tech years.
It gave them a 7-year head start on basically everyone else. If you were a startup in 2010, think Airbnb, Uber, Slack, Pinterest, you didn't even think about buying servers. You just put your app on AWS. It was the default choice. By 2019, they had roughly 40% of the entire global market.
But let's talk about their philosophy. Because Amazon isn't exactly known for being, warm and fuzzy.
No, AWS is known for being fiercely proprietary and ruthlessly efficient. They are a machine. They build their own custom chips, they build their own custom hardware, and they have a reputation for, let's call it strip mining, the open source community.
Strip mining. That is a pretty loaded term. Explain what you mean by that.
There is a famous quote in a TechCrunch article that said, AWS gives open source the middle finger.
Ouch. What do they do to earn that reputation?
Yeah. Here's the playbook. A small company or a community builds a great open source tool. Let's say a database like MongoDB or a search tool like Elasticsearch. It's free, it's popular with developers. AWS looks at it and says, that's great. They take that free code, they wrap it in their own proprietary AWS interface, and then they sell it as a service on their cloud.
So they're directly making money off the free work of the community.
Yes, and the core criticism is that they weren't contributing back. They weren't sharing their improvements or bug fixes with the original project. They were just extracting the value.
Which is legal.
It was perfectly legal under the licenses at the time, but the community hated it. It felt extractive, it felt like a bully move, and it created a lot of bad blood between the open source developer world and Amazon.
Okay, so that is our incumbent. AWS, dominant, proprietary, ruthless, and maybe a bit of a villain to the open source crowd. Now, enter the challenger, Microsoft Azure.
Microsoft knew they couldn't beat Amazon at being Amazon. They were too late to the party. If they just showed up and said, hey, we have servers for rent too, they would lose on price and brand habit. They had to play to their own unique strengths.
And what was Microsoft's superpower? It wasn't cool startups.
No, it was the enterprise, the suit and tie world.
The unsexy stuff.
The incredibly profitable stuff. Microsoft already had contracts and relationships with 95% of the Fortune 500. They had a sales force of 20,000 people. Amazon had amazing tech, but they didn't have 20,000 people who knew the CIO of Coca-Cola on a first-name basis.
So Microsoft used their Rolodex as a weapon.
They did. But they also needed street cred with the developers. And remember, developers hated Microsoft. They were the evil empire from the 90s.
So how do you win over the rebels?
You buy the rebel base.
That's a good way to put it.
In 2018, Microsoft did something absolutely shocking. They bought GitHub for $7.5 billion.
For those who don't know, explain what GitHub is. Why was that so huge?
GitHub is the Library of Alexandria for code. It is where almost all open source software lives and is developed. If you are a coder, GitHub is your portfolio, it's your workspace, and it's your social network, all rolled into one.
So the company of no bought the home of open source.
And the developer community collectively panicked. Oh no, Microsoft is going to ruin it. They're going to make it proprietary. They're going to spy on us.
But they didn't do any of that.
No. And this was the absolute masterstroke by Nadella. They let it run independently. They kept it open. It was a massive $7.5 billion signal to the world. It said, we are the home of open source now. It was a direct counterattack against the AWS reputation of strip mining.
That is such a smart pivot. It's reputation laundering on a massive, massive scale.
It really is. And they also had a different technical strategy, which was just as important, the hybrid cloud.
This feels crucial. What exactly is hybrid?
So AWS, for a long, long time, was a purist. Their message was, everything should be in the public cloud, move all your data to our servers, shut down your basement data center.
It was come to the future, all or nothing.
Right. But Microsoft looked at their existing customers, banks, hospitals, governments, and said, we know you can't move everything.
And why not? Why couldn't they?
A couple of reasons. One is regulations. You can't put certain patient data on a public server in some countries. The other is just physics, latency. If you are running a factory, you can't have a 2-second delay while a signal goes to a data center in Virginia and back. You need the server right there on the factory floor.
So Microsoft's message was, we will meet you where you are.
The Earth is a big place. That was their motto. They said, keep some of your servers in your basement. We'll sell you a product called Azure Stack to run on them and move some to our cloud, and we will make them work together seamlessly.
So that hybrid strategy was the bridge that the big old companies needed. It wasn't this terrifying all-or-nothing choice.
Exactly. It allowed legacy companies to feel safe moving slowly into the future.
Okay, so we have AWS, the first mover, Azure, the enterprise hybrid player. But there is a third player, Google.
Google Cloud Platform, or GCP?
They are the distant third in this race, which is kind of shocking. I mean, Google is Google. They basically invented the modern internet infrastructure.
It's a really interesting case of structure following strategy, or maybe a lack thereof. Google is a tech-heavy, pure engineering company, and their cloud platform is, by many measures, technically brilliant.
They're the best at some things, right?
Oh, yeah. Best in AI with things like TensorFlow. They invented Kubernetes, which is a critical piece of modern infrastructure we will talk about in a minute. They have a strong open source heritage.
Well, there's always a but.
But they struggled with the human element. They just did not have the enterprise culture. They didn't have the sales relationships.
And I remember hearing stories that Google engineers would literally tell huge customers, "You're using our tool wrong," instead of asking, "How can we help you solve your problem?"
That is the most Google thing ever. They assumed the best tech would just win on its own. Corporations felt like Google didn't understand their needs for things like, customer support. They felt Google was a consumer company, an ad company that was just dabbling in business software.
So what was their strategy to try and get back in the game?
Their big bet was on multi-cloud. They pitched themselves as the Switzerland of clouds.
The neutral party.
Exactly. They said, look, don't go all in on Amazon. Don't get locked in. Use us to manage your applications across both AWS and Azure.
Which brings us to a phrase that strikes fear into the heart of any CTO. Vendor lock-in.
Section 4. This is the nightmare scenario that keeps executives up at night.
Why is it such a big deal? I mean, I'm kind of locked into my iPhone ecosystem, and I'm fine with it.
It's a matter of scale and cost. Imagine you build your entire company's operations, your entire house, on a plot of land that you are renting. You spend millions building this beautiful house, and then the landlord decides to double the rent, or change the rules, or he just stops fixing the plumbing.
Okay, so I move the house.
But you can't. In the cloud, moving the house means moving petabytes, maybe exabytes of data. And it means rewriting millions of lines of code that are deeply hooked into that landlord-specific proprietary plumbing.
And the landlords, the cloud providers, they know this.
Oh, they count on it. It's part of the business model. They make it very, very easy and cheap, often free to put data in. Bring us your data. The first terabyte is on us. But getting your data out,
That's where they get you.
that is called egress, and they charge massive fees for it.
It's punitive.
It's the Hotel California of data. You can check out anytime you like, but you can never leave.
Precisely. So how do companies fight back against this? Well, it's innovation again, this time through standardization.
We mentioned the word containers earlier. Is this where they come in?
Yes, this is a really crucial concept. Think of a physical shipping container, the big metal boxes you see on ships and trucks.
Before shipping containers, you had to load a ship with individual barrels, sacks, and wooden crates of all different sizes. It was slow, it was messy, and every ship was packed differently.
And if you wanted to move that cargo from a ship to a truck, you had to unpack everything by hand and then repack it onto the truck.
Right. It was a nightmare of logistics. Containers standardized it. A standard box fits on a ship, a train, or a truck. It doesn't matter who owns the truck, the box just fits.
So what's the software equivalent?
In software, a container, and the most famous tool for this, is called Docker wraps your code and all its dependencies in a standard digital box.
So theoretically, I can pick up my app from AWS and just drop it onto Azure, and it will run without any changes.
That is the promise. And Kubernetes, which, remember, Google invented and then gave away for free, is the software that acts like the giant pork crane. It's the system that orchestrates and manages all those containers.
So but Google gave away the tool that makes it easier for customers to leave Amazon.
Exactly. That was their multi-cloud strategy. If they can commoditize the underlying infrastructure, if they can make all the clouds look the same from the application's point of view, then they break Amazon's lock-in. It dramatically reduces the switching costs.
This brings up the ethics of all this. We talked about AWS strip mining. How does the open source world protect itself from being eaten by these giants?
This is a deep legal and philosophical rabbit hole, but it's fascinating. Open source uses licenses to efface its rules. The most famous one is the GPL, the General Public License. It operates on a principle we call copyleft.
Copyleft, I like that.
It's clever, right? It says, essentially, if you use this free code and you distribute it to someone else, you are legally required to share your changes back to the world. It's share and share alike.
Sounds fair. Keep the innovation flowing.
But there was a massive loophole. The license specifically said if you distribute. In the cloud, AWS isn't giving you a CD-ROM. They aren't distributing the software to you. They are running it on their servers and just letting you access it over a network wire.
The service loophole. I didn't give you the software, I just let you use it so the license doesn't apply.
Exactly. So they could take GPL code, modify it, make it better for their internal systems, and not share any of it back. This enraged the community, so they invented a new license. The AGPL, the Afro General Public License.
And what does that one do?
It specifically closes the service loophole. It says, even if you just run this software over a network, even if you don't distribute the file itself, you still have to share your source code changes.
So it's a constant arms race between the open source lawyers and the corporate innovators.
It is. And Microsoft, interestingly, has positioned itself as the good citizen in this fight. They are saying, we will play by the community rules, we will contribute back, we will support you. It's a complete 180 from their 1990s reputation, and it's a very potent strategic weapon against Amazon's reputation.
It's just amazing how the soft stuff, reputation, community, trust becomes a hard business asset in these wars.
Absolutely. Innovation isn't just about writing code. It's about business model innovation. It's about community innovation.
Okay, let's zoom out geographically for our last section. Section 5. We talked about clusters in the beginning, Silicon Valley, the sweater makers in Modena. Why does geography still matter so much in the cloud age? I mean, if everything is on the internet, why are all these companies clustered in Seattle and Silicon Valley?
It goes right back to that idea of tacit knowledge. You can't email the complex, unspoken know-how of how to build and operate a hyperscale data center. That knowledge lives in people's heads.
And people like to live near other people who do the same kind of work, who speak the same language.
And crucially, they change jobs. The Schilling text talks about the mobility of engineers. An engineer leaves Microsoft, goes to Amazon, then maybe leaves to start their own company. They carry that tacit knowledge with them. It pollinates the entire region. That's why you see these massive clusters. Seattle has become the undisputed cloud capital of the world because Microsoft and Amazon are both there.
It's like a gravity well for talent. If you want to work in cloud computing, you move to Seattle. And because all the talent moves to Seattle, the companies build their new offices there. It becomes a self-reinforcing loop.
Exactly.
So looking forward from our 2019 perspective, where is that talent going? What is the next frontier for the cloud? The sources mentioned the intelligent cloud and the edge.
The edge is a really cool concept. For the last decade, the mantra has been to push everything to the central cloud. Send your data to the big data center.
But now the pendulum is swinging back.
It has to because of physics again. Light is fast, but it is not instant. Latency is real. If you have a self-driving car, you cannot wait 100 milliseconds for a signal to go to the cloud and back to tell you to brake because a kid ran into the street.
The decision has to be made locally.
The compute has to happen right there on the car. That is the edge.
Or in a factory.
Right. The case study mentions Jabil, a big electronics manufacturer. They use Azure AI-powered cameras to spot tiny defects on their assembly lines. The camera is the edge device. It sees the defect, processes the image instantly, and flags the part. It doesn't need to ask the mothership in the cloud for permission.
And then there is the HoloLens, Microsoft's mixed reality headset. That seems like the ultimate edge device.
It is. It's overlaying digital data directly onto the real world, powered by the immense data in the cloud, but rendered locally, right in front of your eyes.
And what's even further out, the sources mention quantum computing.
The holy grail. Microsoft is betting huge on this. And to be clear, this isn't just a faster version of the computer on your desk. It is a fundamentally different kind of physics.
It uses qubits instead of bits.
Right. And that allows you to solve certain types of optimization problems that would take a classic supercomputer a billion years to crack. Things like designing new molecules for medicine, creating new materials, or breaking modern cryptography. Microsoft's timeline in 2019 was that a usable quantum computer was within 10 years. We're still waiting for that big breakthrough. But if Azure can be the first to offer quantum as a service, that changes the game all over again.
Wow. So we have gone all the way from the invention of the pill cam, this clever outsider idea, to the massive planet-spanning industrial scale of Azure's data centers and quantum ambitions. What's the synthesis here? What are we supposed to learn from all this?
I think the core lesson is that innovation is a system. It is not just the eureka moment in a lab. Microsoft didn't invent the cloud. You could argue Amazon did. But Microsoft innovated on the business model. They pivoted from licensing to services. They innovated on culture, pivoting from closed to open.
And they succeeded not by destroying their enemy, which was the old Microsoft way, but by becoming the champion of the very thing they used to hate open source.
It's a profound lesson in adaptability. The knowledge trap we talked about at the very beginning. Microsoft was deeply trapped in the Windows paradigm. Ray Ozzie, and especially Satya Nadella, they were the internal outsiders who managed to break the company out of that trap.
It's a really powerful story. But before we go, I want to leave our listeners with a final provocative thought, a question to chew on.
I've been thinking about this cloud war dynamic. We have three giants, Amazon, Microsoft, Google, that essentially own the world's computing infrastructure.
It's an oligopoly, for sure.
It is. And think back to the user innovation we celebrated at the start. The sailboat guys, the doctors with the super glue, they had agency. They could tinker. They owned their tools. But in a world where the computer is no longer on your desk, but is distributed across these global data centers owned by $3 trillion companies, does the individual user still have the power to innovate in the same way?
That is the question. If I want to invent the next big thing, I have to rent the tools from one of these three landlords. I have to play by their rules, pay their egress fees.
If the tools, the platforms, and the powerful AI models are all rented, who actually owns the knowledge in the end? Are we building on the cloud, or are we just feeding it our data and our creativity?
Have we, in a strange way, outsourced our own creativity to the infrastructure giants?
That's a slightly terrifying thought to end on.
But that is why we do these deep dives, to find the questions that really matter.
Indeed.
Thank you for listening. Keep looking for those outsider perspectives. Watch out for functional fixedness in your own life, and we will see you on the next deep dive.